Hi, welcome to another show. This time I'll be doing limits for various competitive exams. It's a first period topic, mainly for CET, JE, NDA, any other competitive exams. I'll be doing the synopsis part of this. I'll be explaining all the formulas connected to limits, and also with examples, I'll be explaining all the concepts. One by one, we shall discuss the limits for various competitive exams. The various topics covered in this, the first one is the left hand limit and right hand limit. Left hand limit and right hand limit. Indeterminate forms 0 by 0, infinity by infinity, 1 to the power infinity, infinity minus infinity, 0 into infinity, 0 power 0, infinity power 0, various indeterminate forms. Algebra of limits, evaluating limits using factorization. You can factorize numerator and denominator, cancel the common terms, then apply limit. Limits involving using the rationalization, that is, if there is square root or cube root, we rationalize, multiply and divide by the conjugate and simplify it, then apply the limit. Limit at infinity, as x tends to infinity, 1 by x tends to 0, 1 by x square tends to 0, such things I'll be discussing. Limit at infinity. L'Hopital's rule, one of the most familiar results or the technique of evaluating the limits, applicable whenever it takes 0 by 0 or infinity by infinity form. L'Hopital's rule. For CET level, Karnataka CET level, most of the questions we can solve by using L'Hopital's rule. It's applicable mainly when it takes 0 by 0 or infinity by infinity form. Then only we can apply L'Hopital's rule, differentiating both numerator and denominator separately. Infinite series expansion. This is particularly for GE exams. We got series expansion, infinite series expansion for e power x, e power minus x, log 1 plus x, log 1 minus x, sin x, cos x, tan x. I can give general formula using Maclaurin series, infinite series expansion. Some standard limits, trigonometric limits already studied in first PU. Limit x tends to 0, one of the most familiar results. Limit x tends to 0, sin x by x equal to 1. Limit x tends to 0, tan x by x equal to 1. X is measured in the radian, correct? All those things we know. More trigonometric limits we will discuss, not only those two. Exponential and logarithmic limits, that is, limit x tends to 0, e power x minus 1 by x equal to 1. Limit x tends to 0, log of 1 plus x divided by x equal to 1, such things. With examples, I'll be doing all these things. Sandwich theorem, one of the most familiar theorem called sandwich theorem. Two functions are given to you, f and h. G of x is sandwich between f and h. Such kind of result we have. Sandwich theorem, one of the most important. It's required even for J exams. Newton-Leibniz formula, where integral of some function will be given to you. You want to evaluate the limit of that. Finding unknowns when the limit is finite and 1 to the power infinity form. Some of them are particularly required for JE exams. I'll tell you, 1 to the power infinity they won't ask for Karnataka CET level. Normally they can ask for JE exams. Even Newton-Leibniz formula applicable and useful for JE exams, JEE exams, JE main, JE advanced, and infinite series expansion also useful for J exams. Sandwich theorem too, okay, particularly for J exams. One by one we shall take now. First of all, to understand what is left hand limit and right hand limit. LHL stands for left hand limit. Limit x tends to a minus f of x is called as left hand limit. What do you understand by left hand limit? Left hand limit means value of x is approaching a from the left side. Suppose I represent here x equal to a. Suppose x equal to a is some real number. Okay. X equal to a is some real number. Okay. X tends to a minus means what do you understand? X is approaching a from the left side. X is approaching a from the right side is this, a plus. A minus means the value of x is slightly less than a. X tends to a minus means the value of x is slightly less than a. X tends to a plus means the value of x is slightly greater than a. A minus a plus is right hand limit. Okay. So x tends to a minus could also be written as h tends to 0, put x equal to a minus h. A minus means, suppose take an example, x tends to 2 minus. 2 minus means what do you understand? The value of x is slightly less than 2, say 1.99 such a value or 1.999 such a value. That means what? 1.999 is 2 minus some value, correct? X tends to 2 minus. 2 minus means 2 minus some positive value, correct? So x tends to a minus means h tends to 0, put x equal to a minus h, correct? X tends to 2 minus means 2 minus some positive value, that is h. So x equal to a minus h. X tends to a plus means h tends to 0, put x equal to a plus h. What do you understand by x tends to, say 2 plus? 2 plus means what? 2 plus means slightly greater than 2. Value of x is slightly greater than 2. Say 2.000001, such a value. That means 2 plus some positive value. X tends to 2 plus means what? X is equal to 2 plus some positive value. So x tends to a plus means h tends to 0, put x equal to a plus h. These kind of simplification is required normally when we have greatest integer function or fractional part function or signum function like that. Okay, normally we need to simplify using these techniques. Okay, we find normally left hand limit and right hand limit separately when the problem involves modulus function, greatest integer function, this is fractional part function, square root function. Okay, then function defined piecewise. Function defined in two pieces. Suppose they define like this, f of x equal to x square. Suppose I give like this, f of x is equal to x square for x less than 0. I define like this, f of x equal to 2 minus x for x greater than or equal to 0. If you want to find the left hand limit, if you want to find limit x tends to 0, then we find left hand limit and right hand limit separately. That is, the function is defined in pieces, we call function defined piecewise. This is called piecewise because there are two pieces, x less than 0 one function, x greater than or equal to 0 another function, correct? So x square for x less than 0, 2 minus x for x greater than or equal to 0. So the function f of x is defined in pieces. That's why piecewise defined function we call. So whenever the given function involves modulus function, greatest integer function or fractional part function, this is fractional part function, flower bracket, square root function, we find left hand limit and right hand limit separately and then conclude whether limit is going to exist or not. Limit exists only if left hand limit and right hand limit both are equal. Both should be finite. Limit exists only if left hand limit becomes equal to right hand limit. Both should be finite. Okay, then only limit of a function is going to exist. So this is more about the left hand limit and right hand limit are given here. X tends to a minus means x approaches a from the left side. That is, value of x is slightly less than a. X tends to a plus means value of x is slightly greater than a. A minus and a plus. Okay, left hand limit and right hand limit. Some of the indeterminate forms, as I told earlier, 0 by 0, infinity by infinity, infinity minus infinity, 1 to the power infinity, 0 into infinity, infinity into 0, 0 power 0, correct? Infinity power 0, all those things are indeterminate forms. Normally we have 7 indeterminate forms frequently used. 0 by 0, infinity by infinity, we can apply L'Hopital's rule for these two. Whenever we get 0 by 0, infinity by infinity, we can apply L'Hopital's rule. 1 to the power infinity, there is a separate formula for that. All these things rarely used. 0 into infinity. Sometimes we may come across infinity minus infinity normally when it involves a square root. Square root of 1 plus x square, some kind of limit x tends to, when it takes infinity minus infinity, x tends to infinity, then I give like that. So there also some problems are there, but not so much. 1 to the power infinity is very familiar for JEE exams. 0 by 0, infinity by infinity commonly asked for CET, even NDA exams also. CET, NDA exams, you can see these kind of questions. 0 by 0, infinity by infinity. These are the various indeterminate forms. 7 indeterminate forms. Once again I tell, 0 by 0, infinity by infinity, infinity minus infinity, 0 into infinity, 1 to the power infinity, infinity power 0, 0 power 0. These are the 7 indeterminate forms. So algebra of limits. Next we have f and g be two real functions. A belongs to R, the set of real numbers. Limit x tends to a, f of x exists, and limit x tends to a, g of x exists. Limit of f and limit of g both exist as x approaches a. Then limit of the sum is sum of the limits. This is the limit of the sum is equal to sum of the limits. Limit of the difference is equal to difference of the limits. Limit of the product is equal to product of the limits. Limit of the quotient is quotient of the limits. And this is limit of lambda f of x. This lambda you can keep outside. Lambda is some constant. Lambda times limit x tends to a f of x. Limit x tends to a f of x power n is limit x tends to a f of x to the power n, where n is a natural number. And limit x tends to a nth root of f of x. If it is given like this, we can apply limit inside the square root or inside the nth root. Okay. And this is of composite function. Limit x tends to a f of g of x is f of limit x tends to a g of x, where f is continuous at g of a. And this is inequality. F of x less than or equal to g of x, then a is some real number, then limit of f of x is less than or equal to limit of g of x. This kind of thing is useful in sandwich theorem. Okay, this is about the algebra of limits. This tells you how to apply the limit. They can ask simple questions based on this also. Suppose I give an example here. Limit x tends to a f of x. I can ask a question like this. Limit x tends to a f of x is equal to say 3. Limit x tends to a g of x is equal to minus 2. And ask you to find what is limit x tends to a f into g of x. F into g of x. How to do this? Limit of f into g is limit of f into limit of g. Just using this, the product of the limits. Limit of f of x into g of x. F g of x is f of x into g of x. By algebra of the real functions we know. I can write f g of x as f of x into g of x. And you know the limit of the product is product of the limits. Limit x tends to a f of x multiplied by limit x tends to a g of x. A can be some other real number also. I can give instead of x tends to a, I can give x tends to minus 1 also. A can be some real number. That doesn't matter for us. I'm just giving an example how to apply. Limit of the product is product of the limits. Limit x tends to a f of x is given to be equal to 3, and limit x tends to a g of x is given to be equal to minus 2. 3 into minus 2 is minus 6. Okay. And also limit of a composite function. Sometimes we may come across like this. Limit x tends to say e of log of some function sin x. Log of sin x I may come across. In that case we can write log of limit x tends to e of sin x. Just an example is given to you to make you understand like this. Okay, x tends to e log of sin x. Log of limit x tends to e sin x. Then apply limit to get log of sin e here. Log of sin e you're going to get. Hope you understand how to apply limit for a composite function. This is useful in sandwich theorem, the last one, where inequality is found. F of x less than or equal to g of x, then limit of f of x less than or equal to limit of g of x. All these things are algebra of limits. This explains how to apply limit for sum of two functions, difference of two functions, product, quotient, constant into function, f of x power n, nth root of f of x, and for a composite function, and if there is inequality, how to apply limit it explains. It's a very basic concept. Take an example here, limit x tends to 0 mod x by x. I told you we need to calculate the left hand limit and right hand limit separately if the given question involves modulus function, greatest integer function, fractional part function, square root function, and when the function is defined piecewise in 2 pieces or 3 pieces. If it is defined, we need to find left hand limit and right hand limit separately, because we don't know limit exists or not in these cases. So we have to find left hand limit and right hand limit separately. So left hand limit I shall find out. Left hand limit is given by limit x tends to 0 minus. Limit x tends to 0 minus is left hand limit. What is the given function? Mod x divided by x. Mod x divided by x. So x tends to 0 minus. 0 minus means what? Slightly less than 0. Left side of 0. Slightly less than 0. Correct? X tends to 0 minus. 0 minus means value of x is slightly less than 0. Approaching 0 from the left side. Left side of 0 we got negative real numbers. For negative real numbers we write mod x as minus x. Minus x divided by x. And this becomes x cancels. Limit of minus 1 is minus 1. Left hand limit is minus 1. Right hand limit what? Right hand limit is limit x tends to 0 plus. Limit x tends to 0 plus is right hand limit. Given function is mod x divided by x. 0 plus means what? Do you understand? The value of x is approaching 0 from the right side. From the right side. Slightly greater than 0. Say 0.1 or it can be 0.001 or 0.0000001. Such a small value. Slightly greater than 0. 0 plus means slightly greater than 0. So this is equal to limit x tends to 0 plus. For x is positive, we write mod x is x. X by x is 1. Limit of 1 is 1. Limit of a constant is constant. You see that left hand limit is minus 1 and right hand limit is plus 1. So left hand limit is not equal to right hand limit. Limit of the function does not exist. This question was asked in CET exam in fact. Left hand limit is not equal to right hand limit. So what is the conclusion? Limit x tends to 0, mod x by x does not exist. Limit x tends to 0, mod x by x does not exist. Hope you understood this. Very simple question, commonly asked question. So whenever there is modulus function, greatest integer function, fractional part function, square root function, when the function is defined in pieces, piecewise function I call. Okay, in these cases we need to find left hand limit and right hand limit separately, so that we can conclude if they are equal, if left hand limit is equal to right hand limit, if both are finite and equal, then the limit of the function is going to exist. The common value is going to be the limiting value in that case. Hope you understand this. Mod x means there are two cases. For 0 minus means the value of x is approaching 0 from the left side. Left side of 0 is negative values. For negative values, mod x is minus x. 0 plus means right side of 0, approaching 0 from the right side. For right side of 0, we got positive real numbers. For positive real numbers, mod x is x. X by x, 1. Limit of 1, 1. So left hand limit is minus 1. Right hand limit is plus 1. They are not equal. LHL not equal to RHL. Limit of x tends to 0. Mod x by x does not exist. Concepts of limits are very much useful in differentiation and also useful in continuity of a function. They are all related to each other. Limits, continuity, differentiability, application of derivatives, they are slightly climbing up and up. Integration, application of integrals, differential equations, all belong to the calculus part. So they are related topics. Okay, so quite interesting also. Move on to the next one. This is a solution given to you. Next one, the question is this. Limit x tends to 0 of greatest integer function. Greatest integer function you have to find out. Limit x tends to 0 minus and 0 plus I need to find. Left hand limit and right hand limit separately because it involves the greatest integer function. I should find out left hand limit. Limit x tends to 0 minus. X tends to 0 minus of the given function. Greatest integer function. 0 minus means what you understand? Value of x is slightly less than 0. Slightly less than 0 means we can take a value say minus 0.1. In the mind, you can take a value minus 0.1. What is greatest integer value of minus 0.1? Greatest integer value of minus 0.1 is going to be equal to minus 1. Correct? Left hand limit is minus 1. Right hand limit you take. Right hand limit. Limit x tends to 0 plus. Limit x tends to 0 plus of greatest integer function. 0 plus means what? Slightly greater than 0. Say 0.1 you take in the mind. Roughly for just understanding purpose. Greatest integer value of 0.1. Greatest integer value of 0.1 is 0. Correct? which are integers less than or equal to 0.1. Integers less than 0.1 are 0, -1, -2, -3, so many other. Among them, greatest is 0. That's called the greatest integer less than or equal to the given number. Correct? Thus, once again, I can conclude that left hand limit is not equal to right hand limit. Therefore, limit of the function does not exist. Limit x tends to 0 of greatest integer function does not exist. See, the beauty of this greatest integer function is not only you take x equal to 0, x tends to 0. I can take x tends to any integer value. Integer value means what? 0, plus or minus 1, plus or minus 2, plus or minus 3. Any integer value you take, limit of x tends to integral value of the greatest integer function does not exist. That is guaranteed. Limit x tends to which value of greatest integer function is going to exist? I should take a non-integral value. Only for non-integral value, limit of the greatest integer function is going to exist. That is such an important concept. Even in continuity also we come across this. I'll demonstrate one more example here. Add a new page here. Say, if you want to find limit x tends to say 5 minus of greatest integer function. What do you understand by 5 minus? 5 minus means not minus 5. 5 minus means the value of x is slightly less than 5, say 4.99. What is greatest integer value of 4.99? It is going to be equal to 4. For understanding purpose, I am writing a number. Okay, actually we don't have to write the number there. Just for understanding purpose, I am writing a particular number. So this becomes 4. If I ask what is limit x tends to 5 plus of greatest integer function. 5 plus means what? The value of x is slightly greater than 5. Say 5.01. Integral value of 5.01 is equal to how much? Integral value of 5.01 is equal to 5. See, you observe that left hand limit is not equal to right hand limit. Therefore, limit of greatest integer function does not exist whenever they give x tends to integer value. So I can conclude that the conclusion is that limit x tends to a of greatest integer function does not exist. Does not exist for all a belongs to z. For all a belongs to z. Z is the set of integers. For every integral value, limit x tends to a of greatest integer function does not exist. If you take a non-integral value, what do you understand by non-integral value? Say 0.2, 1.33 or 2.7 or root 2, root 3 or pi. They are all non-integral values. If you take any non-integral value and evaluate, say for example, I take limit x tends to 1.7 minus. Limit x tends to 1.7 minus of greatest integer function. What do you understand by 1.7 minus? 1.7 is a non-integral value. 1.7 minus means what? Slightly less than 1.7. Say 1.69. What is the greatest integer value of 1.69? What is the greatest integer value of 1.69? It is 1, correct? If you take a number line, here 1 is there, here 2 is there. 1.69 may fall somewhere here, correct? 0, -1, -2, etc. Which are the integers less than 1.69? 1, 0, -1, -2, many are there. Among them, greatest is 1, right? That's my greatest integer less than or equal to given number. What do you take if you take limit x tends to 1.7 plus? 1.7 plus of greatest integer function. 1.7 plus means what? Slightly greater than 1.7. 1.71. You take 1.71 roughly. Just for understanding purpose, I am taking a particular number. What is greatest integer value of 1.71? It is 1 itself. So limit exists because left hand limit is equal to right hand limit. So remember that limit x tends to a of greatest integer function. If it has to exist, this a should be what? Non-integral value. That is r minus z. It should be a non-integral value. Then only limit of that function is going to exist. Limit x tends to a. Limit x tends to a, greatest integer function exists for all a belongs to r minus z. r minus z denotes what? The non-integral value. From the set of real numbers, you remove all the integers, we get the non-integral value. So limit x tends to a of greatest integer function exists means that should be a non-integral value only. Understood? Solution is given to you here. And next one, I got factorization method. Before that, I can add one more slide here and explain to you how to find the left hand limit and right hand limit for a function which is defined in pieces. F of x equal to say 3 minus x. This is for x less than or equal to 0. Okay. Then x square plus 2. This is for x greater than 0. Find out left hand limit and right hand limit at x equal to 0. X tends to 0 minus f of x, and find out limit x tends to 0 plus f of x. Find out this. 0 minus means what? Slightly less than 0. X should be less than 0. See, x less than or equal to 0, the function is defined as 3 minus x. For x greater than 0, the function is defined as x square plus 2. Correct? So x less than or equal to 0 is to be used for left hand limit. This is a function to be used for left hand limit. X greater than 0 is to be used for right hand limit. So the function is defined in pieces. That's why piecewise defined function I can call. X tends to 0 minus. 0 minus means x less than 0. The function is 3 minus x. 3 minus x. That is equal to 3 minus 0, which is equal to 0. Correct? Limit x tends to 0 plus. 0 plus means what? X is greater than 0. That is, the function is x square plus 2. X square plus 2. X equal to 0, you put 0 square plus 2 is equal to 2. Therefore, left hand limit is not equal to right hand limit. Correct? This is left hand limit and this is right hand limit. Left hand limit is not equal to right hand limit. Therefore, limit of the function does not exist. Sometimes they can ask the quadratic equation. You have to form a quadratic equation whose roots are left hand limit and right hand limit of this function. What is the left hand limit? We got 3. What is the right hand limit? We got 2. One such question was asked in CET exam, I think in 2022, KCET. The question was asked like this. A function was given like this. The function defined in as a piecewise function. You have to form a quadratic equation whose roots are alpha and beta. Alpha is left hand limit and beta is the right hand limit. If you know the roots of the quadratic equation, we can form a quadratic equation, right? We know the familiar equation, x square minus sum of the roots into x plus product of the roots equal to 0. Correct? So I can form the quadratic equation using this left hand limit and right hand limit. They should mention the sentence that left hand limit is left hand limit and right hand limit are the roots of the equation. Okay, then you form the quadratic equation. In that case, I call this as alpha and this as beta. What is the quadratic equation if they ask? X square minus sum of the roots into x plus product of the roots equal to 0. That is the quadratic equation to be formed. So what we get? X square minus sum of the roots 3 plus 2. Correct? 3 plus 2 into x. 3 into 2 equal to 0. X square minus 5x. I'll write the answer here. X square minus 5x plus 6 equal to 0. That's the equation. That is a quadratic equation whose roots are left hand limit and right hand limit at x equal to 0. So hope you understand. When the function is defined in pieces, we can find out left hand limit and right hand limit. Hope you understand this. This is about the factorization. Suppose they give limit x tends to a f of x by g of x. Suppose it takes a 0 by 0 form. If you apply the limit directly, if it takes 0 by 0 form, in that case, what we do is we're going to apply the limit. And if it takes 0 by 0, we can factorize numerator and denominator. Suppose x minus a is a factor. In that case, you factorize the numerator and denominator and cancel out the common terms and then apply the limit. Okay, limit x tends to a, or else you can apply L'Hopital's rule, differentiating numerator and denominator separately, because it takes LH rule I given here. LH rule is L'Hopital's rule. I'll be explaining this later also once again. L'Hopital's rule is just differentiate the numerator and denominator separately. okay, and apply the limit until that indeterminate form is removed. You keep on differentiating numerator and denominator separately until that 0 by 0 form or infinity by infinity form, indeterminate form is removed. L'Hopital's rule is applicable for 0 by 0 as well as infinity by infinity form. Here I am discussing 0 by 0 form, okay. So numerator and denominator are some polynomial functions given to you. When you apply the limit, suppose it takes 0 by 0, and you can factorize. You are able to factorize both the polynomial. So if you factorize numerator and denominator and cancel out the common terms and then apply the limit, you can get some finite number. That means indeterminate form will be removed. Okay, that is the factorization method. And rationalization method is also given here. Particularly if it involves square root, cube root, etc. We rationalize, multiply and divide by conjugate. One such result are given here. Limit x tends to 0, root of a plus x minus root of a minus x by x. We can rationalize here. Suppose I give limit x tends to 0 here. Limit x tends to 0. What we have? Root of a plus x minus root of a minus x divided by x is there, correct? You multiply and divide by root of a plus x plus root of a minus x. Multiply and divide by the conjugate of the numerator here. Root of a plus x plus root of a minus x. Here use a plus b into a minus b. A square minus b square. X tends to 0. A minus b into a plus b is a square minus b square. A plus x minus, correct? I am using the formula a minus b into a plus b, correct? A square minus b square. A square minus b square formula. Root of a plus x square is a plus x. Root of a minus x square is a minus x divided by x into root of a plus x plus root of a minus x. Here a is going to cancel. X minus minus x, 2x. I'll write here limit x tends to 0. What I'm going to get is limit x tends to 0. Numerator is 2x divided by denominator is x into root of a plus x plus root of a minus x. X cancels. Apply limit now. Numerator is 2. Denominator is root of a plus 0. Correct? Plus root of a minus 0. A plus 0 is a root a. Root a plus root a. Correct? I'll write here. 2 divided by root a plus root a is 2 root a. 2 cancels. What we get is 1 by root a. 1 by root a. Correct? Can remember this. Or else I can apply L'Hopital's rule. If you apply the limit directly, no, x equal to 0 here. X equal to 0. Root of a plus 0 minus root of a minus 0. Correct? Root a minus root a is 0. 0 by 0 it becomes. 0 by 0. Correct? I'm getting a 0 by 0 form. So we can apply L'Hopital's rule. Differentiate numerator and denominator separately and then apply the limit. What do you get? If you apply L'Hopital's rule here, instead of rationalization, I can apply L'Hopital's rule. Derivative of root x. I assume that you know the derivatives formula. Derivative of root of a plus x is what? 1 by 2 root of a plus x into derivative of a plus x. Of course, a is a constant. Derivative of constant is 0. 0 plus 1. 1. Correct? Into 1 minus derivative of root a minus x 1 by 2 root of a minus x into derivative of a minus x minus 1. Differentiate denominator derivative of x1. Now apply limit x equal to 0. This will become 0. This will become 0. Correct? Minus into minus plus. What we get is 1 by 2 root a plus 1 by 2 root a. That is 1 by root a. It's a half plus half. It is like half less half. 1. 1 by 2 root a plus 1 by 2 root a is 2 by 2 root a, which is 1 by root a. Hence we can rationalize, or else we can apply L'Hopital's rule. L'Hopital's rule says differentiate numerator, differentiate denominator separately. Don't apply quotient rule. Quotient rule is a different story. Just differentiate the numerator and denominator separately, then apply the limit. Continue this process of differentiating numerator and denominator until that 0 by 0 form is removed, until the indeterminate form is removed. You can continue this process. I've got the finite number 1 by root a. It's not 0 by 0. So I can stop there. An example is given here. In this problem, you see, it involves a square root, no? So we can rationalize one method. Otherwise, I can apply L'Hopital's rule. But before applying L'Hopital's rule, just check whether it takes 0 by 0 or not. When you put x equal to 3, what do you get? 3 cube minus 27. Put x equal to 3 directly. Root of, what do you get? 2 into 3, 6 plus 3 minus root of 3 into 3, 9. Correct? 3 cube is 27. 27 minus 27 is 0. Root 9 minus root 9, 0. Correct? Root 9 is 3. 3 minus 3 is 0. It takes 0 by 0 form. If you apply the limit directly, we get 0 by 0 form. If you take 0 by 0 form, one can apply L'Hopital's rule. So apply L'Hopital's rule here. Apply L'Hopital's rule. Differentiate numerator and denominator separately. I am applying L'Hopital's rule. So differentiate the numerator and denominator separately. What do you get? Limit x tends to 3. Differentiate numerator. Derivative of x cube, 3x square. Derivative of 27, 0. Divided by, 27 is a constant. Derivative of constant is 0. Derivative of root of 2x plus 3 is what? 1 by 2 root of 2x plus 3 into derivative of 2x plus 3, that is 2, minus derivative of root of 3x is 1 by 2 root of 3x into derivative of 3x is 3. Now you can apply limit. Put x equal to 3. That is 3 into 3 square divided by here 2 cancels. What you get is 1 by root of 2 into 3, 6. 6 plus 3. Correct? Root of 6 plus 3 minus 3 by 2 root of 3 into 3, 9. So this is 3 square, 9 into 3, 27. This is 1 by root 9. Root 9 is 3. So 1 by 3 minus, here root 9 is same as 3. 3 cancels. 1 by 2. Take LCM in the denominator. 3 into LCM is 6. 3 2s are. So 2. 2 3s are. Correct? This 6 will go up. 6 into 27. 27 into 6 divided by minus 1, which is minus 162. Hope you understand this. If it takes 0 by 0 form, differentiate numerator and differentiate denominator separately. Then apply the limit to get the answer, which is 0 by 0 form is removed. Answer is minus 162. Next we got limit at infinity. As n tends to infinity, 1 by n tends to 0. Infinity is indication of a large number, large number, such a large number. You can't imagine. It can have more and more number of digits. It can have infinite number of digits. Such a large number it is. As n tends to infinity, 1 by n tends to 0. Even 1 by n square tends to 0, etc. given. And limit n tends to infinity, a power n is 0 if a lies between minus 1 and plus 1. You can take an example. Say you take limit n tends to infinity of half power n. Half power n. Half is a number between 0 and 1, correct? So half square how much? Half square is 1 by 4. Half cube is 1 by 8. As you increase the power, no, the number becomes smaller and smaller, correct? If you do 1 by 2 square, it is 1 by 4. If you do 1 by 2 cube, it is going to be equal to 1 by 8. It is becoming still small. Correct? If you do 1 by 2 to the power 500, it is very close to 0. And if you do 1 by 2 to the power n, where n is tending to infinity, correct? Infinity is such a large number. 1 by 2 power 500 only tends to 0. I am just giving an example, numerical example, counter example. This will definitely tend to 0. So limit n tends to infinity, a power n will become 0 if the value of a lies between minus 1 and plus 1. And third and fourth, these kind of questions, this kind of concept was used even in 2025 CET exam this time. As x tends to 0 minus, 1 by x tends to minus infinity, and e power 1 by x tends to e power minus infinity, which is 0. X tends to 0 minus, 1 by x will tend to minus infinity. That is 0 minus means what? Slightly less than 0. Such a small value, slightly less than 0, negative value, small negative value, correct? 0 minus. 1 by x will tend to minus infinity. In that case, e power 1 by x will tend to e power minus infinity, which tends to 0. Here x tends to 0 plus, 1 by x tends to plus infinity, e power 1 by x will tend to e power infinity, which is tending to infinity. Why this happens here like this? because e power infinity is infinity and e power minus infinity is 0. You must be knowing that the value of e is greater than 2. Correct? E is approximately 2.71828. So if a number is greater than 1, I can extend this result. See, one more I can write here actually. If n tends to infinity is given, I can write a power n. Limit n tends to infinity, a power n is going to become equal to infinity if a is greater than 1. If a is greater than 1. I'll give some more examples here to understand this. Suppose I give limit n tends to infinity. Limit n tends to infinity. 5 power n is how much, can you tell? 5 is a number greater than 1, correct? If you do 5 square, 25. 5 cube, 125. Number is increasing, no? As you increase the value of n, 5 power n becomes large and large. So as n tends to infinity, 5 power n will become infinity, I can tell. Tends to infinity, in fact. Limit n tends to infinity. Suppose I give 7 to the power n. 7 is a number greater than 1, right? 7 square 49, 7 cube 343. So number becomes more and more. As you increase the value of n, 7 power n becomes quite large and large. So I can write this as infinity. Suppose I give limit n tends to infinity of 1 by 5 to the power n. 1 by 5 means what? It is 0.2, correct? 1 by 5 is 0.2. 0.2 to the power n. If you do 0.2 square, it becomes 0.04. 0.2 cube, it becomes still less. 0.008, like that. Correct? So, as you increase the value of n, 0.2 power n will tend to 0. Correct? That is what we write. So, that is what we have the case. That is, limit n tends to infinity. Limit n tends to infinity. A power n is equal to 0 if that value of a lies between -1 and +1. And if I give like this, limit n tends to infinity, a power n will become infinity if a is greater than 1. If a number is greater than 1, greater than 1 power infinity is infinity. If a number lies between -1 and +1 to the power infinity is equal to 0. And that is how we are. And if I give like this, limit x tends to infinity, limit x tends to infinity, e power x will be what? Infinity. Because e power infinity is infinity. What is e actually? The value of e is 2.71828. The value of e is approximately 2.71828. So e power infinity is infinity. Remember this. If I give like this, limit x tends to infinity, e power minus x. E power minus x. It becomes e power minus infinity. E power minus infinity is 1 by e power infinity. Actually, this becomes 1 by e power infinity. What is e power infinity? Infinity. 1 by infinity, 0. So, x tends to infinity, e power minus x is 0. Okay, you must be knowing this. That is what the explanation was given in the previous slide. So many examples, so many note was given. X tends to 0 minus, 1 by x will tend to minus infinity. So, e power minus infinity, 0. E power infinity is infinity. E power infinity is infinity because e is 2.71828. 2.71828 power infinity is infinity because 2.71828 is greater than 1. Greater than 1 power infinity is infinity. If a number is between -1 +1 to the power infinity is 0. Quite simple. Understood? If a number is greater than 1 to the power infinity, it is going to be infinity. Here, e power minus infinity, why it is becoming 0? E power minus infinity is 1 by e power infinity. Correct? E power infinity is infinity. 1 by infinity becomes 0. Hence, e power minus infinity is 0. Okay? And this also I can give the proof here. This is also based on this above result only. These two results. Limit n tends to infinity, a power n plus b power n to the power 1 by n is a. If a is greater than b is greater than 0. I'll give a proof of that and give examples also based on that. Limit n tends to infinity, look at this. Limit n tends to infinity, a power n plus b power n to the power 1 by n. They told a is greater than b is greater than 0. Correct? So I can write this as, even though nothing is common, I'll take a power n out from this. A power n out. Bigger number is a power n, correct? So a power n if you take out, what remains? 1 plus b power n divided by a power n whole to the power 1 by n. Taking a power n out. A power n into 1, a power n. A power n into b power n by a power n is b power n. So this becomes equal to what? Limit n tends to infinity. Now you see a power n power 1 by n, that is a. A you can keep outside. A power n power 1 by n. The powers gets multiplied, that is a kept outside. So what is left out now? 1 plus b by a to the power n. B power n by a power n is b by a whole power n. Entire thing is raised to the power 1 by n. You observe that b by a is less than 1, no? Because a is greater than b, I'll divide by a on both sides. 1 greater than b by a. That means b by a, 0 by a is 0. So b by a is a number between 0 and 1, no? If a number lies between 0 and 1, a number lies between 0 and 1, power infinity is going to become 0. This is going to be 0. So what is left? A into 1 plus 0 to the power, apply limit n tends to infinity here, correct? 1 by infinity is 0, 1 to the power 0 is 1, so a into 1, a is the answer. Understood? So this is the result. Limit n tends to infinity, a power n plus b power n to the power 1 by n is equal to a if a is greater than b is greater than 0. Same type of result we have for another one. Limit n tends to infinity, I can add one more slide here. Limit n tends to infinity. Limit n tends to infinity, we have a power n plus b power n plus c power n to the power 1 by n is equal to a if condition a is greater than, b is greater than, c is greater than 0. All are positive and a is the highest number. So the proof of this, you take limit n tends to infinity, a power n out from this. Nothing is common. Forcibly I am taking a power n out. So what do you get? A power n out. What remains? 1 plus b power n divided by a power n plus c power n divided by a power n whole to the power 1 by n is equal to limit n tends to infinity. What we have? A power n power 1 by n is a. A power n to the power 1 by n is a. Correct? What is left out? 1 plus b by a to the power n plus b power n by a power n is b by a whole power n. C power n by a power n is c by a whole power n. Correct? Whole to the power 1 by n. A I can keep outside because it is independent of the limits. Limit n tends to infinity. So what is left out here? 1 plus b by a to the power n, c by a to the power n plus c by a to the power n whole to the power 1 by n. See that b by a is a number less than 1. You can divide the entire equation by a. So 1 is greater than b by a, greater than c by a. B by a is less than 1, c by also less than 1. Less than 1 power infinity is 0. Less than 1 power infinity is 0. 1 plus 0 plus 0 is 1. 1 to the power 1 by infinity. 1 by infinity is 0. So 1 to the power 0 is 1. This entire thing becomes 1. 1 into a equal to a. This becomes a into 1 plus 0 plus 0. 1 by infinity is 0. 1 to the power 0 is 1. A into 1 is equal to a. Hence the proof. Hope you understand this. Make a just note of this. Okay. Remember this result. All these things required here and there. The concepts even for JEE exams. Example is given. If you want to see the previous slide, I was explaining about this. One more result was there here. I can explain this also. Then I can take examples. Limit x tends to infinity. This is numerator is polynomial. Denominator is also polynomial. Numerator polynomial of degree m, because you see the highest power of x is m here. And denominator is a polynomial of degree n because highest power of x is n. So in this case what happens? A naught by b naught. That's called ratio of the leading coefficient. If degree of numerator equal to degree of denominator. Degree of numerator equal to degree of denominator. It is ratio of the leading coefficient. Here degree of numerator is less than degree of denominator, then the ratio becomes 0. And if degree of numerator is greater than degree of denominator, a naught b naught is positive. A naught b naught, the leading coefficient product is positive, then becomes infinity. A naught b naught is less than 0 and degree of numerator is greater than degree of denominator, then it becomes minus infinity. I'll explain this by taking examples. Okay. And also you can note down these formulas here. Make a note of this summation of n. These formulas are quite useful here. 1 plus 2 plus 3 plus etc. n. Sum of the first n natural numbers denoted by summation of n. Summation of n is what? N into n plus 1 divided by 2. Sum of the first n natural numbers. This is quite useful to work out the problems. That's why I'm giving this. 1 square plus 2 square plus 3 square etc. n square. Sum of the squares of the first n natural numbers. Summation of n square is equal to n into n plus 1 2n plus 1 divided by 6. Sum of the squares of the first n natural numbers. Sum of the cubes of the first n natural numbers. 1 cube plus 2 cube plus 3 cube etc. n cube. This is nothing but summation of n cube. Summation of n cube is equal to what? N square into n plus 1 the whole square divided by 4. Sum of the cubes of the first n natural numbers. N square into n plus 1 the whole square divided by 4. Okay. All these things you should learn. Summation of n square and summation of n cube. I'll take up problems now on this. This already gave the result. Limit n tends to infinity. A 2 power n plus 3 power n plus 5 power n to the power 1 by n. What is the answer? 5. 5 is the answer directly. Because this is the highest number, that's the answer, right? Already gave the result. Limit n tends to infinity. What we gave? A power n plus b power n plus c power n whole to the power 1 by n. What is the answer? A. If A is greater than B, is greater than C, is greater than 0. All are positive and the highest number is going to be the answer. Here highest number is 5. So 5 is the answer. Answer is 5 directly. Already the proof is given for this. If you want, you can try this. Steps are given, I think. Directly I use the result and wrote the answer. Okay. And this one. Limit n tends to infinity. This appeared in KCET 2009. Quite interesting question. So here what we do is, if you apply limit directly, it can take infinity by infinity form. Correct? Infinity minus infinity, all those things. Indeterminate forms. So I'll simplify this. Limit n tends to infinity. 3 into 2 power n plus 1 I can write. 2 power n into 2 power 1. Minus 4 into 5 power n plus 1 I can write 5 power n into 5 power 1 divided by 5 into 2 power n plus 7 into 5 power n. This dot is multiplication. So this is equal to limit n tends to infinity. What we have? 3 into 2 is 6. 6 into 2 power n minus 4 into 5. 20 into 5 power n divided by 5 into 2 power n plus 7 into 5 power n. Among 5 power n and 2 power n, 5 power n is bigger, right? So I'll take 5 power n out from this. Limit n tends to infinity. Limit n tends to infinity. 5 power n out from the numerator. So what remains? 6 into 2 power n. To balance it, divide by 5 power n. Minus 20. Denominator you take 5 power n out. So what do you get? 5 into 2 power n divided by 5 power n plus 7. Cancel the common terms. 5 power n cancels. As n tends to infinity, this is 2 by 5 power n. 2 by 5 is a number between 0 and 1. If a number lies between 0 and 1, power infinity is going to be 0. If a number lies between 0 and 1, power infinity is 0. 6 into 0, 0. Minus 20 divided by 5 into 0, 0 plus 7. So answer is minus 20 divided by 7. Note that n tends to infinity. Limit n tends to infinity. I use this result. A power n is equal to 0 if a is between 0 and 1. Or if a lies between minus 1 plus 1 also it becomes. 2 by 5 is 0.4. 0.4 power infinity 0. Here also same story. 6 into 0, 0 minus 20. 5 into 0, 0 plus 7. Minus 20 by 7 is the answer. Hope you understand this. Solution is given here. If you want, you can note down this. Take a screenshot if you want. limit x tends to 0 minus 1 by 3 minus 2 power 1 by x. As x tends to 0 minus, as x is approaching 0 minus, what happens? 1 by x. 1 by x will tend to minus infinity, right? If x tends to 0 plus, 1 by x will tend to plus infinity. As x tends to 0 minus, 0 minus means value of x is slightly less than 0, say minus 0.00000001, such a value. Or you can take minus 10 to the power minus 50, like that value. So 1 by x will be minus 10 to the power plus 50, right? So minus 10 to the power 50 it becomes. 1 by 10 to the power minus 50 with negative sign. So minus 10 to the power 50, which is minus infinity. 10 to the power 50 is such a large number. Just I'm taking example to make you understand. So 1 by x tends to minus infinity. 2 power 1 by x. 2 power 1 by x is what? 2 power minus infinity it becomes. 2 power minus infinity is what? Tends to 0. Because 2 power infinity is infinity. Correct? 2 power minus infinity. 2 power minus infinity is 1 by 2 power infinity. And you know 1 by 2 power infinity is infinity. 2 is greater than 1. Greater than 1 power infinity is infinity. 1 by infinity is 0. Gone. So this becomes 0. 2 power 1 by x is tending to 0. So given limit becomes equal to 1 by 3 minus this entire quantity is tending to 0. So answer is 1 by 3. X tends to 0 minus 1 by x tends to minus infinity. 2 power minus infinity is 0. So 1 by 3 minus 0. 1 by 3 is the answer. Next one. Limit x tends to 0, e power minus 1 by x square. The question is, limit x tends to 0, what is asked? E power minus 1 by x square. See, x tends to 0 plus or x tends to 0 minus. In both the cases, 1 by x square will tend to infinity. Correct? 1 by 0 square is 1 by 0, which is plus infinity. 0 square, if whether it is slightly greater than 0 or less than 0, in both the case x square is positive. So 1 by x square, 1 by 0 becomes infinity. X square is positive in both the cases. 0 minus means negative value. 0 plus means positive value. In both the cases, if you square, x square will become 0. 1 by 0 is infinity. What we want to find? Limit x tends to 0. Limit x tends to 0, e power minus 1 by x square. This is e power minus, what is 1 by x square? Infinity. E power minus infinity is 1 by e power infinity. 1 by e power infinity is infinity. 1 by infinity is 0. Answer is 0. So answer is 0. Next one. Here I can use the summation of n here. Limit n tends to infinity, 1 plus 2 plus 3 etc. and summation of n. Correct? Numerator is summation of n. 1 plus 2 plus 3 plus etc. n. Summation of n divided by n square plus 100. This is equal to limit n tends to infinity. Numerator is summation of n. Correct? N into n plus 1 divided by 2. Divided by n square plus 100. Correct? Applying the formula, summation of n. N into n plus 1 by 2. This 2 comes to denominator, right? Limit n tends to infinity. I can multiply there if you want. N square plus n. This 2 comes to denominator. Dividing by n square plus 100 is multiply by reciprocal. 2 comes to denominator. 2 times n square plus 100. 2 comes down. So now you see, degree of numerator is 2. Degree of denominator is 2. That means both numerator denominator are same degree. Degree means highest power of n here. Both are polynomials, right? Numerator is polynomial, denominator is polynomial. So both have same degree. So what is coefficient of n square here? 1. What is coefficient of n square? 2. So answer is 1 by 2. Over. That's the answer. 1 by 2 is the answer. If you want, I can do the steps here. If you are doing the steps, I'll show the steps how we got it. I use the result actually. One of the results I mentioned, no? I use this result. I use this result. Ratio of the leading coefficient if degree of numerator equal to degree of denominator. Coefficient of highest power of x in the numerator by coefficient of highest power of x in the denominator. That is what I did. I directly used this result and got the answer. If you want, I'll show the steps. Here you see, n square plus n is there, no? From there I'll show. Limit n tends to infinity. What you do? Take n square common there. Even though it's not common, take out. What remains? 1 plus n by n square. Correct? Divided by denominator 2 into, take n square common there. N square out. So what remains? 1 plus 100 divided by n square. Here n square is going to cancel. N by n square is 1 by n. As n tends to infinity, this becomes 1 by infinity. 1 by infinity is 0. 100 by infinity is square, that is also 0. 1 plus 0. Here 2 into 1 plus 0. Applying the limit, we get 1 plus 0 divided by 2 into 1 plus 0. So answer is 1 by 2. Hope you understand this. Degree of numerator equal to degree of denominator. We take ratio of the leading coefficient. One more example is here. Limit n tends to infinity. 1 plus 2 plus 3 etc. n divided by 1 square plus 2 square plus 3 square etc. n square. Numerator is summation of n. Correct? Summation of n. That is what? Limit n tends to infinity. N into n plus 1 divided by 2. Denominator is summation of n square. What is the formula for summation of n square? N into n plus 1, 2n plus 1 divided by 6. N into n plus 1 is going to cancel. 2 1s are, 2 3s are. This 3 goes up. So what we get? Limit n tends to infinity. 3 by 2n plus 1. 3 divided by 2n plus 1. Correct? As n tends to infinity, denominator is becoming infinity. So this becomes like something like this. 3 by infinity, which is equal to 0. Answer is 0. Over. Solution is given. Next one. Numerator is summation of n square here. Correct? What is summation of n square formula? N into n plus 1, 2n plus 1 by 6. N into n plus 1, 2n plus 1 divided by 6. Denominator is already given as a polynomial of degree 3. 4n cube plus 6n square minus 5n plus 1. See, degree of denominator is 3. That means denominator is polynomial of degree 3. Numerator, if you open the bracket and multiply, n into n, I'll get n cube. 2n cube we get, in fact, correct? So the coefficient of n cube is going to be 2, correct? Highest power of n is 3 in the numerator. So degree of numerator is 3, degree of denominator is also 3. Degree means highest power of n, correct? So highest power of n in the numerator is 3, denominator also 3. So I can take the ratio of the leading coefficient. What is coefficient of n cube in the numerator? When you multiply n into n, I'll get 2n cube. So coefficient of n cube is 2. Divided by 6 is there, that will keep as it is. Divided by coefficient of n cube in the denominator is 4. 2 by 6 is 1 by 3. 1 by 3 divided by 4. Answer is 1 by 12. Over. Such a simple question. Answer is 1 by 12. Here it's given 1 by 12. 1 by 12. Degree of numerator equal to degree of denominator. And these are some of the standard results. Okay. We can use L'Hopital's rule because if we take 0 by 0 form, we can apply L'Hopital's rule and get the answer. Already studied in 11th standard these results. Correct? X power m, x power n actually, not m, x power n. Limit x tends to a, x power n minus a power n. X power n minus a power n divided by x minus a is equal to n into a power n minus 1 for all n belongs to q. And another one is just an extension of that. Please go through it. Go through it. Example is given here. Here, if you apply the limit directly, we can use the formula, that formula which I gave you in the previous slide, or else you can apply L'Hopital's rule and get the answer. Because when you directly apply the limit, now it becomes 0 by 0 form. Put x equal to minus 3. Minus 3 cube is minus 27 plus 27, which is 0. Denominator is minus 3 power 5 minus 243 plus 243. Correct? Denominator also 0. 0 by 0 form. One can apply L'Hopital's rule and get the answer. Apply L'Hopital's rule. Differentiate numerator and denominator separately and simplify it. Apply the limit. What do you get? Limit x tends to minus 3. Derivative of x cube is 3x square. Derivative of 27 is 0. Derivative of x power 5, 5x power 4. Derivative of 243 is 0. Apply limit x equal to minus 3. 3 into minus 3 square divided by 5 into minus 3 power 4. Minus 3 square 9. 9 into 3 is 27. Minus 3 power 4 is 81. 81 into 5, that is 405. Correct? Or else I can cancel, I think, here. 3 table. I could have cancelled minus 3 square. Correct? Also, now I'll simplify it. 3 9s are 27. 3 into 13. 1 3. Correct? 135. Further I can simplify. 3 3s are and 3 45s are. So 1 by 15 is the answer. I could have simplified here only. Minus 3 square to cancel. Correct? 1 by 15 is the answer. 1 by 15. Next one. Infinite series expansions. Please learn all these infinite series expansion. E power x, e power minus x, all these things. E power x is 1 plus x square by 2 factorial plus x cube by 3 factorial, etc. up to infinity. E power minus x, 1 minus x plus x square by 2 factorial minus x cube by 3 factorial plus x power 4 by 4 factorial, etc. up to infinity. Alternate plus minus. Log 1 plus x minus x square by 2 plus x cube by 3. Log 1 plus x minus x square by 2 plus x cube by 3 minus x power 4 by 4, etc. up to infinity. Log 1 minus x, minus of, replace x by minus x, minus and kept out, minus of x plus x square by 2 plus x cube by 3 plus x power 4 by 4, etc. up to infinity. 1 plus x whole power n, 1 plus nx plus n into n minus 1 by 2 x square plus n into n minus 1 n minus 2 by 3 factorial into x cube. 3 factorial is 6. All these things you learn. Series expansions. Even a power x also you can learn. 1 plus x by 1 factorial into log a, x square by 2 factorial into log a the whole square plus x cube by 3 factorial into log a the whole cube. All series expansions you need to learn. Sin x, cos x, tan x. Sin x is x minus x cube by 3 factorial plus x power 5 by 5 factorial minus x power 7 by 7 factorial, etc. up to infinity. Cos x 1 minus x square by 2 factorial plus x power 4 by 4 factorial minus x power 6 by 6 factorial, etc. up to infinity. All these have infinite series expansion. Also tan x is given by x plus x cube by 3 plus 2 by 15 x power 5 up to infinity. Sin inverse x, tan inverse x, if possible, remember. All these things can be deduced using Maclaurin series expansion. Maclaurin series expansion is given here. F of x equal to f of 0 plus x into f dash of 0 plus x square by 2 factorial into f double dash of 0 plus x cube by 3 factorial into f triple dash of 0, etc. up to infinity. All the above series expansions what I wrote can be deduced using this formula, Maclaurin series expansion. More generally this is. Okay. And one of the famous theorem we know already are given here, sin x by x equal to 1 we know. I can prove sin x by x equal to 1 using this Maclaurin series expansion. I shall prove it. See, limit x tends to 0, sin x by x equal to 1 we know, right? Limit x tends to 0, sin x by x is equal to 1. Correct? Actually what is happening here is whether as x tends to 0 minus or x tends to 0 plus. 0 plus or 0 minus, in both the cases what happens is sin x by x is there, no, it is slightly less than 1. In fact, sin x by x is slightly less than 1 and x by sin x is slightly greater than 1. If a number is slightly less than 1, reciprocal of that is going to be slightly greater than 1. Remember this. So please make a note of this. As x tends to 0 plus or x tends to 0 minus, in both the cases sin x by x is tends to 1 minus. 1 minus means not minus 1. 1 minus means indication of a number which is slightly less than 1, 0.999. We write equal to 1. Correct? What is the idea of limit actually? Limit x tends to 0, sin x by x equal to 1 means as x is approaching 0, sin x by x is approaching 1 and we write equal to 1. That's the idea of limit actually, concept of limit. So x tends to 0 plus or 0 minus, sin x by x is tends to 1 minus and x by sin x is tending to 1 plus. Slightly greater than 1. Reciprocal of a number slightly less than 1 is going to be slightly greater than 1. Same story for tan x also. Tan x by x. As x tends to 0 minus or x tends to 0 plus. In both the cases, what happens is tan x by x is slightly greater than 1. Okay. 1 plus, alright. And x by tan x is going to be slightly less than 1. tends to 1 minus. X by tan x slightly less than 1. Tan x by x is slightly greater than 1. You should know these concepts, because while if I give some problem like this, I'll give a problem. For example, find limit x tends to 0 of greatest integer value of 100 into tan x by x. In that case, you should know the exact value where it is when a greatest integer function is given. Such kind of questions can be asked in JEE exams also, JEE exams. Such kind of questions can be asked. That's why I'm giving the exact values. Tan x by x is slightly greater than 1 as x tends to 0. As x tends to 0, sin x by x is slightly less than 1. So if you take tan x by x is slightly greater than 1 point something, correct? 1 point something into 100 will be 100 point something. So I can write this as 100 into tan x by x is what? Slightly greater than 1. Now I can apply the limit inside here. So 1 plus h, where x is slightly greater than 0. So h is such a small positive number. 100 into 1, 100. 100 plus something, means 100 point something. So greatest integer function becomes 100 in that case. Suppose I ask same question, limit x tends to 0, 100 into sin x by x. Sin x by x is slightly less than 1, correct? In that case, what happens? I'll write here. Limit x tends to 0. Suppose I ask greatest integer value of 100 into sin x by x. In that case, what? As x tends to 0 minus or 0 plus, in both the cases, sin x by x is slightly less than 1. So this is a number slightly less than 1. So I can write this as limit h tends to 0, 100 into 1 minus h. That will be what? 100 into 100, 100 minus a small positive number. 100 minus a small positive number means 99 point something. Greatest integer value of 99 point something is 99. So hope you understand the difference between these two. Sin x by x slightly less than 1 as x tends to 0. And tan x by x is slightly greater than 1 as x tends to 0. Okay. And I can prove using Maclaurin series expansion. I mean the series expansion. Sin x. You take x common. Sin x by x I can find out, and I can apply the limit using series expansion and reduce sin x by x equal to 1. I'll write here itself. We know this series expansion for sin x. What is sin x? X minus x cube divided by 3 factorial plus x power 5 divided by 5 factorial minus etc. up to infinity. You take x common from this. What we get? 1 minus x square divided by 3 factorial is 6. Plus x power 4 divided by 5 factorial is 120 minus etc. up to infinity. From this we take sin x by x. Sin x by x what? Sin x by x is equal to 1 minus x square by 6 plus x power 4 divided by 120 etc. up to infinity. Now take limit x tends to 0 for this. Limit x tends to 0. Sin x by x. Correct? Taking limit x tends to 0 on both sides. From this, can you observe that I'm going to get right hand side as slightly less than 1? Are you observing this? Etc. See, x is a small positive quantity. 1 minus some small positive quantity. X square. X is so small, x square is still small. X power 4 is still small. Correct? 1 minus say 0.01 plus 0.3 times 0.1 like that. So if you subtract a small value, say 0.1, 1 minus 0.1, 0.9. 0.9, you add still smaller number, it is 0.9 something. 0.9 something, then subtract smaller number, then add still smaller number, then subtract still smaller number. Like that you go on continue. This resultant quantity will be less than 1, right? Slightly less than 1. Hence, I can tell you that as x tends to 0, sin x by x is slightly less than 1. It's very clear from this. And we write limit x tends to 0, sin x by x equal to 1. Of course, using Sandwich theorem, we prove it. I proved using the Maclaurin series or series expansion for sin x. Same I can prove for tan x also. Tan x I can prove. So tan x, what is the series expansion we have? Tan x is equal to, we have series expansion, x plus x cube divided by 3 plus 2 by 15 x power 5. You can take x common from right hand side. X is common. So what remains? 1 plus x square divided by 3 plus 2 by 15 x power 4 etc. up to infinity. From this you write tan x by x. tan x divided by x is equal to how much? 1 plus x square divided by 3 plus 2 by 15 x power 4. You can see everywhere plus sign is there. Take limit x tends to 0 for this. Tan x. Limit x tends to 0, tan x by x. Taking limit on both sides, x tends to 0. I can see 1 plus some positive value, right? 1 plus x square divided by 3 plus 2 by 15 x power 4 etc. up to infinity. Correct? 1 plus a small positive value plus still small positive value. Everywhere you can see plus plus plus. Obviously this number is slightly greater than 1. Hence I told as x tends to 0, tan x by x is slightly greater than 1. Whereas x tends to 0, x by tan x is slightly less than 1. Reciprocal of this will be slightly less than 1. X tends to 0, sin x by x slightly less than 1. X tends to 0, x by sin x will be slightly greater than 1. If a number is slightly less than 1, reciprocal will be slightly greater than 1 and vice versa. And this is the limit of trigonometric limits. Limit x tends to 0, sin x by x equal to 1, x is measured in radian. Limit x tends to 0, tan x by x equal to 1, x is measured in radian. These are familiar results we already proved in first PU. Correct? Sine of an angle by same angle is 1. Also we have limit x tends to 0, sin ax by sin bx, a by b. Limit x tends to 0, tan ax by tan bx, a by b. Limit x tends to 0, sin ax by bx, a by b. Limit x tends to 0, tan ax by bx, a by b. All are a by b from this. And also we got limit of inverse trigonometry function. Limit x tends to 0, sin inverse x by x is 1. I can prove this if you want. So look at this. And you can take this as homework. So you put sin inverse of x, any inverse trigonometry function represents angle, no? So put sin inverse of x equal to theta. Put sin inverse of x is equal to theta. That means x is equal to sin theta. X is equal to sin theta. As x tends to 0, theta also tends to 0, correct? As x is approaching 0, x is approaching 0, sin inverse of 0 is 0, theta is also tending to 0. So from this, what I can write, limit x tends to 0 is same as theta tends to 0. Sin inverse of x are taken as theta and x will be sin theta from this. So theta by sin theta. We know theta tends to 0, theta by sin theta is 1 because sin theta by theta is 1, reciprocal of 1 is 1. Hence proved. Same way I can make a proof of this. Limit x tends to sin x by sin bx, a by b. That's the application of this. And if angle x is given in radian, no, you convert it to degrees. Suppose again limit x tends to 0, sin x degree by x. Sin of x degree divided by x is given. Then what you do, you convert it to radian. X degree is pi x by 180 radian, okay? Sin of x degree. X degree is how much? Pi x by 180 radian. Then you can multiply and divide by pi by 180. Because sine of an angle by same angle is 1. Correct? Multiply and divide by pi by 180. Sine of an angle by same angle is 1. 1 into pi by 180. Answer is pi by 180. Hope you understand this. That is how we can prove all these things. Limit x tends to 0. Multiply and divide by ax here. Multiply and divide by x. Sin ax by x1. Multiply and divide by bx. Correct? Sin bx by bx1. So what do you get? Ax by bx. X cancels. A by b. Understood? And also limit x tends to 0, cos x equal to 1. Limit x tends to a, sin x minus a by x minus a equal to 1. Because x tends to a means x minus a tends to 0. Sin of an angle by same angle is 1. Tan of an angle by same angle is 1 as x tends to a. So all these things you must know. Limits are involving trigonometric functions. And there is one example here. I am using this to evaluate this. I will use this result. Limit x tends to 0, sin ax by sin bx, a by b. Limit x tends to 0, sin ax divided by sin bx is equal to how much? A by b, right? Use this technique. So what do you get? This is apply limit for all. This is 10 by 9 into limit x tends to 0, sin 9x by sin 10x is 9 by 10. So first bracket is simplified. Second bracket, 8 by 7 you keep as it is. Limit x tends to 0, sin 7x by sin 8x, 7 by 8. Next bracket, 6 by 5 keep as it is. Apply this result. So answer is a by b. Coefficient of x in the numerator 5. Coefficient of x in denominator is 6. Here 4 by 3 into, this is sin 3x by sin 4x, 3 by 4. And here sin x by sin 2x, that is 1 by 2. Each bracket is 1, right? Each bracket is 1. So answer is 1 into 1 into 1 into half. Half is the answer. Hope you understand. Repeatedly applying this. Limit x tends to 0, sin ax by sin bx, a by b. Hope you understood the proof of this. What I did there? Multiply and divide by ax. Because sine of an angle by same angle is 1. Sin ax is divide by ax, multiply by ax. Sin bx here also. Multiply and divide by bx. Sin bx divided by bx. Sin ax by ax is 1. Sin bx by bx is 1. X cancels. What we get is a by b. Understood? That is what we use in each bracket, and the last bracket is 1 by 2. Each bracket is 1 there by first 4 brackets, and answer is half. Hence, solution is given. Next one. Can you work out this? Limit theta tends to 0. L and M are given like this. You have to form the quadratic equation whose roots are L and M. 3 sin theta minus 4 sin square theta. Simplify this. L is equal to limit theta tends to 0. Numerator take sin theta common. What remains? 3 minus 4 sin theta divided by theta. Sine of an angle by same angle is 1. So what is left out? 1 into 3 minus, for this apply limit, sin 0, 0, 0 into 4, 0. So 3 is the value of L. Same way find out M. M is what? Limit theta tends to 0. You can apply tan theta by theta is 1. Correct? Or you can use this formula 2 tan theta by 1 minus tan square theta is tan 2 theta. Correct? Tan 2 theta divided by theta. Tan ax by bx is a by b, 2 by 1. Coefficient of theta is 2. Coefficient of theta is 1. 2 by 1 is equal to 2. So we take this as alpha and beta, or L and M is given already, no? So no need to take. So we can form the quadratic equation whose roots are L and M. So required quadratic equation is what? X square minus sum of the roots 3 plus 2 into x plus product of the roots 3 into 2 equal to 0. X square minus sum of the roots into x plus product of the roots equal to 0. Hence the solution is given here. Next one. Limit x tends to pi. Sin x by x minus pi. If you apply limit directly, sin pi is 0. Correct? Pi minus pi is also 0. You can apply L'Hopital's rule. Differentiate numerator and denominator separately. Apply L'Hopital's rule. Differentiate numerator and denominator separately. What we get? Limit x tends to pi. Differentiate numerator, derivative of sin x, cos x. Differentiate denominator, derivative of x1, derivative of pi 0. Apply limit x equal to pi, cos pi is equal to minus 1. Differentiate numerator and denominator separately and get the answer. Answer is minus 1. Some more results are given connected to trigonometric function. We can prove all these things one by one, and some of them are very important, frequently asked in CET exams. Limit x tends to 0, 1 minus cos x by x equal to 0. If you apply limit directly, cos 0 is 1. 1 minus 1, 0. 0 by 0. L'Hopital's rule I can apply. So differentiate numerator denominator separately. Limit x tends to 0. What we get? Derivative of 1, 0. Derivative of minus cos x is plus sin x. Divided by derivative of x is 1. So this becomes sin 0 is equal to 0. Hence proved. Limit x tends to 0. 1 minus cos x by x is 0. Limit x tends to 0, 1 minus cos x by x square is half. So very important one. This is already asked in CET exam directly as this question itself. 1 minus cos x by x square is half. I can prove using L'Hopital's rule because it takes 0 by 0 form. If you apply limit directly here, cos 0 is 1, 1 minus 1, 0, 0 by 0. So apply L'Hopital's rule. What we get? Limit x tends to 0. You differentiate numerator. Derivative of 1, 0. Derivative of minus cos x is plus sin x. divided by derivative of x square is 2x. So sin x by x is 1, no, as x tends to 0. So 1 by 2. Hence proved. Next one is see, limit x tends to 0, 1 minus cos differentiate using L'Hopital's rule, differentiate numerator, denominator separately. Derivative of 1, 0. Derivative of minus cos px is sin px into derivative of px is p divided by derivative of x square is 2x. Differentiate numerator and denominator separately. Sine of an angle by same angle is 1, no? Correct? So multiply and divide by p here. Sin px divided by px is 1. P into p square divided by 2. Hence proved. Same way you can prove the fourth one also. Limit x tends to 0. 1 minus cos px by 1 minus cos qx is p square by q square. If you want to prove it, apply L'Hopital's rule for this problem. Differentiate numerator and denominator separately. Derivative of 1 is 0. Derivative of cos is minus sine. Minus of minus plus sine. Sin px into derivative of px is p. Denominator differentiate. Derivative of 1 0. Derivative of minus cos qx is derivative of minus cos qx is plus sine. Derivative of minus cos is plus sine. Sin qx into derivative of qx is q. Correct? Now I can use sine of an angle by same angle is 1. Correct? Or sin px by sin qx is p by q. Correct? So this is p by q into p by q. Hence we get p square divided by q square. Because sin px by sin qx is p by q. P by q into p by q. P square by q square. Same way can apply L'Hopital's rule for that also. Cos ax minus cos bx by x square. Differentiate numerator and denominator separately. I'll add a slide here. Limit x tends to 0. Cos ax minus cos bx divided by x square. Cos ax minus cos bx divided by x square is equal to what? Apply L'Hopital's rule. If you apply limit directly, it takes 0 by 0 form. Because when you put x equal to 0, a into 0, 0, cos 0, 1. Here also b into 0, 0, cos 0, 1, 1 minus 1, 0, 0 by 0 form. So apply L'Hopital's rule. Differentiate numerator and denominator separately. Apply L'Hopital's rule. We get limit x tends to 0. Derivative of cos is minus sine ax into derivative of ax a. Derivative of cos bx minus sine bx into derivative of bx is b divided by derivative of x square is 2x. Correct? So what we get? Limit x tends to 0. Limit x tends to 0. Here I'll write this term first. Minus into minus is plus. B into sine bx. B into sine bx divided by 2x minus a into sine ax divided by 2x. Correct? So this becomes equal to what? Limit for this. Here sine bx by 2x will be b by 2. Coefficient of x in the numerator by coefficient of x in denominator. Because we know this. Limit x tends to 0. Sine ax by bx is a by b, right? Sine ax divided by bx is equal to how much? A by b. Correct? So sine bx by 2x will be b by 2. So b into b by 2. A into, this will be a by 2. So what we get? B square by 2 minus a square by 2. B square by 2 minus a square by 2. It's equal to b square minus a square divided by 2. Hope you understand. Learn all the results. Then only it is useful to understand, so that you can understand better and better if you know all the formulas, even the trigonometric formulas, differential formulas, integration formulas, all you need to learn. Write and study all the formulas. Mathematics is a subject made up of all formulas only. Also I can prove this last one. Limit x tends to 0. Tan x minus sin x by x cube. Quite important this also. I'll write sin as tan into cos. We know that tan x is sin x by cos x, right? Tan x is sin x divided by cos x. So I'll write sin x as tan x into cos x. Tan x into cos x. Sin is tan into cos. So this becomes what? Limit x tends to 0. Limit x tends to 0. tan x minus what I write for sin x. Sin x is tan x into cos x. Tan x into cos x divided by what we have is x cube. So we can take tan x common. Correct? In the numerator, tan x is common. What is left out? 1 minus cos x divided by x cube. I can write x into x square. Tan x by x is 1 as x tends to 0. We know this. And limit x tends to 0. 1 minus cos x by x square is half. Correct? So 1 into half is equal to half. Please learn this as a standard result. Limit x tends to 0. 1 minus cos x by x square is half. Limit x tends to 0, 1 minus cos px by x square, p square by 2. Limit x tends to 0, 1 minus cos px by 1 minus cos qx, p square by q square. All these three, the results based on this questions are asked in CET exam as well. I'll give you the examples in the next slide. See. Limit x tends to 0, 1 minus cos x by 3 by x square. I am comparing with this. Limit x tends to 0, 1 minus cos px divided by x square. 1 minus cos px by x square is equal to what? P square by 2. Identify that P is 1 by 3 here. Correct? P is how much? 1 by 3. Compare 1 minus cos px. How much is P? P is 1 by 3. So what is the answer for this? P square by 2. P is 1 by 3. 1 by 3 square divided by 2. 1 by 3 square is 1 by 9. 1 by 9 by 2 is 1 by 18. P square by 2, just identify that P is 1 by 3. Answer is 1 by 18. Next one, limit x theta tends to 0. Question asked in KCET 2017. I'm using this result. Limit x tends to 0. What is the result we have? Just now proved. 1 minus cos px divided by 1 minus cos qx is equal to what? P square divided by q square. So limit instead of x tends to 0, the given theta tends to 0. Identify that P is 4 and Q is 6. So what is the answer? 4 square divided by 6 square. 4 square 16, 6 square 36. So answer is 4 by 9 over. Crack the answer in just 5 seconds. 4 square by 6 square. 4 square 16, 6 square 36. Correct? 16 by 36. 4 by 9 over. Simple question. Here I am using the result. Limit x tends to 0. Cos ax minus cos bx by x square. Cos ax minus cos bx divided by x square. What is the result? Just now proved. Remember all these things. Make a note of this. B square minus a square by 2. So a is 9, a is 7, b is 9. So what is the answer? B square minus a square divided by 2. How much? 9 square 81. 7 square 49 divided by 2. How much? 32 by 2 16. B square minus a square divided by 2. Next one. Oh, this also we proved already. Correct? Tan x minus sin x by x cube. Now it's given slightly modified form. Tan x minus sin x divided by sin cube x is given. So what we do is you multiply and divide by x cube. Multiply and divide by x cube here. Correct? What we get? Sin cube x by x cube is 1. Sin x by x the whole cube, which is 1. 1 cube 1. So what is left out now is limit x tends to 0. Tan x minus sin x by x cube. Already we proved this. Answer is half. Tan x minus sin x by x cube is equal to half. Using two results. Correct? One is I use tan x by x1. Another one I use 1 minus cos x by x square is half. I wrote tan as sin into cos. Sin as tan into cos. I wrote sin as tan into cos, then take tan x common, tan x into 1 minus cos x by x into x square. Tan x by x1, 1 minus cos x by x square is half. 1 into half. Answer is half. As x tends to 0, answer is half. Solution is given here. Please make a note of this. Next one more result we have. Sin power mx by tan power m of bx. Answer is a power m by b power m, where m is natural number. And one more result is given here in terms of sin bx and tan and dx. And if you take the power sum, k plus m should be p plus q. That condition should be satisfied. Sum of the powers of x in the numerator should be same as sum of the powers of x in the denominator. Powers of x and powers of tan function there. So please make a note of this result. I'll give example for this. Question is given like this. The power of sine and power of tan is same, no? So I can apply the result and write the answer. What is the answer for this? 2 cube divided by 5 cube. 2 cube is 8. 5 cube is 125 over. That's the answer. Power of sine and power of tan is same. The answer is coefficient of x how much? 2. So 2 cube. Coefficient of x how much? 5. 5 cube. 2 cube by 5 cube. Answer is 8 by 125. The application of sin x by x equal to 1 and tan x by x equal to 1 as x tends to 0. Okay. In the previous slide, we had this result. Based on this, the question was framed. And here, sum of the powers of x and sine function. So it should be same as sum of the powers of x and tan function. Sine, tan and x. Only such kind of function should be present. That is what given here. K plus m equal to p plus q. K is the power of sine here. M is the power of x. And here p is the power of tan and q is the power of x. So only the coefficients will come out. A power k, b power m divided by c power p into d power q. That's the answer. I'll give example for this. Okay. See here, the power of sine is 3 here. Correct? Power of x is 5. 5 plus 3 how much? 3 plus 5 is 8. In the numerator, sum of the power of x and sine is 8. In the denominator, power of tan is 6. What is power of x? 2. 6 plus 2, 8. Both have same, no? Sum of the powers of sine and x in the numerator should be same as sum of the powers of tan and x in the denominator. Then you take the coefficient. What is coefficient of x here? 3. So answer is 3 cube into. What is coefficient of x power 5? 32. Here what is coefficient of x2? So 2 power 6. That coefficient of x should be raised to that power there. Here coefficient of x square is 3. 1 3 is going to cancel. 3 square remains. 3 square is 9. 9 into 32 divided by 2 power 6 is 64. 32 ones are 32s are. Answer is 9 by 2. Hope you understand this. Just take the coefficients of x in the numerator denominator. Raise it to appropriate powers as given in the question. Answer is 9 by 2. That is what we got. And this is one more concept. As x tends to infinity, 1 by x tends to 0. And hence limit x tends to infinity, x into sine 1 by x. You can write limit x tends to infinity, sine 1 by x by 1 by x. X is written as 1 by 1 by x. As x tends to infinity, 1 by x tends to 0. Sine of an angle by same angle is 1. Note that as x tends to infinity, 1 by x is tending to 0. So what I am having is limit x tends to infinity is same as 1 by x tending to 0. What we have is sine 1 by x divided by 1 by x, which is equal to 1. Next one we have exponential and logarithmic limits. Please learn all these things. Limit n tends to infinity, 1 plus 1 by n to the power n is e. Limit x tends to 0, e power x minus 1 by x is 1. Limit x tends to 0, a power x minus 1 by x is log a base e. The power and denominator should be same here. See, a power x minus 1 by x. Power is same as denominator. Here also the power is same as denominator. Limit x tends to 0, log 1 plus x by x1. Log of 1 plus something by same thing is 1. Here the base is e, here the base is a. So it becomes log e base a. Log e base a is 1 by log a base e. Okay. And this is limit x tends to 0, 1 plus x power 1 by x equal to e. The definition of e, these two will give the definition of e. This is exponential and logarithmic limits. I'll give some examples connected to this. Here, limit x tends to 0, log 1 plus x, 3x square is there. We know that limit x tends to 0, log of 1 plus x by x is 1. Limit x tends to 0, log of 1 plus x divided by x is 1. Log of 1 plus something by same thing is 1. So 1 plus 3x square is there, no? Log of 1 plus 3x square. What do you do? Divide by 3x square and multiply by 3x square. Divided by x into, here e power 5x minus 1 divided by 5x multiplied by 5x. Log 1 plus 3x square by 3x square is 1. E power 5x minus 1 by 5x is 1. The power and denominator should be same, correct? I'm using these two theorems. Limit x tends to 0, e power x minus 1 by x is 1. Correct? E power 5x minus 1 by 5x 1. So multiply and divide by 5x. This becomes 1. This becomes 1. What is left out? 1 into 3x square, 3x square. Limit x tends to 0. What is left out now? 3x square divided by 5x square. X square is going to cancel. Limit of 3 by 5 is 3 by 5. Answer is 3 by 5. Next one. Limit x tends to 0. E power x square minus cos x divided by x square. So for this, what we should do is, we know this theorem. Limit x tends to 0. 1 minus cos x by x square is half, right? We know this. 1 minus cos x by x square is half. It's a very familiar trigonometric limit. Limit x tends to 0. E power x square minus 1 by x square is going to be equal to 1. Correct? So this problem has two parts here. So to write this in terms of these two limits, I'll make some adjustment here. What I'll make is, you add 1 and subtract 1 here. This is equal to limit x tends to 0. What we can write is e power x square is there. Put minus 1. Then you put plus 1. Minus cos x. What I did, subtract 1, add 1. Rest all kept as it is. E power x square minus cos x. E power x square minus cos x as it is. Divided by x square. Correct? So what we get? Limit x tends to 0. Limit x tends to 0. Separate the terms. E power x square minus 1 by x square plus 1 minus cos x divided by x square. Correct? This is equal to how much? As you know, as I wrote here already, e power x square minus 1 by x square is 1. 1 minus cos x by x square is half. 1 plus half, 1 and half, 3 by 2. Simple question based on the two results. 3 by 2 is the answer. Please make a note of this. Next one. Limit x tends to 0. X into e power x minus sin x by x. Here easily we can separate the terms. See, numerator is difference of two terms. No, I'll separate x into e power x by e power x. X into e power x divided by x minus sin x by x. Separating the terms. What we get? X cancels. What we get? Limit x tends to 0. E power x minus sin x by x. We know e power 0 is 1. As x tends to 0, sin x by x is 1. Here e power 0 is 1. And as x tends to 0, sin x by x is 1. 1 minus 1, 0. Question asked in KCD 2016. Such a simple question. Answer is 0. Next one. We got 1 to the power infinity form. 1 to the power infinity form. Learn this formula. Limit x tends to a, f of x power g of x is given by e power limit x tends to a, g of x into f of x minus 1. The base should approach 1 and the power should approach infinity. The base is f of x and the power is g of x. As x is approaching a, the base f of x should approach 1 and the power g of x should approach infinity. In that case, we have this formula. Okay, e power limit x tends to a, g of x into f of x minus 1. It's called as 1 to the power infinity form. Frequently asked in JEE exams. Okay, and one more formula. This is not much useful. Sometimes you may require it. So given it, limit x tends to a, f of x power g of x is equal to e power limit x tends to a, g of x into log f of x using the property of log. F of x power g of x written as e power limit x tends to a, g of x into log f of x. Not much useful. The first one is most important. Please learn it. Okay, 1 to the power infinity form. I give an example here. Limit x tends to 0, cos x power 1 by x. If you apply the limit directly, what happens? This becomes cos 0. Cos 0 is 1. 1 by 0, infinity. 1 to the power infinity form. Correct? So we can apply that formula. F of x power g of x. F of x power g of x what? If it is given like this, f of x to the power g of x, limit x tends to a, f of x to the power g of x is equal to what? E power limit x tends to a, g of x into f of x minus 1. G of x into f of x minus 1. This is a formula. So limit x tends to 0, cos x to the power 1 by x. Cos x to the power 1 by x is equal to what? E power limit x tends to 0. E power limit x tends to 0. G of x into f of x minus 1. Correct? F of x power g of x. E power limit g of x into f of x minus 1. From this, what we can write is e power limit x tends to 0. I can pull out a negative sign from this. Minus of 1 minus cos x divided by x. 1 minus cos x by x is 0. E power minus 0. Same as e power 0, which is 1. Answer is 1. Already we know this is standard limit. Limit x tends to 0. 1 minus cos x by x is 0. Such an important limit it is. Don't forget it. So e power minus 0. Same as e power 0. 1 is the answer. Solution is given here. Please make a note of this. Next one more example is given. Limit x tends to 0. Tan of pi by 4 plus x to the power 1 by x. If you apply the limit directly, no, pi by 4 plus 0 is pi by 4. Tan pi by 4 is 1 to the power 1 by 0, infinity, correct? So it becomes 1 to the power infinity form. So we can use this formula. Limit x tends to 0, e power, limit x tends to 0, g of x. G of x means write the power first. This is the power, correct? G of x into f of x minus 1. Tan of pi by 4 plus x minus 1. Hope you understand this. F of x for g of x is e power limit g of x into f of x minus 1. So this is equal to e power limit x tends to 0. What we have? 1 by x into, what is tan of pi by 4 plus x formula? 1 plus tan x divided by 1 minus tan x. Correct? 1 plus tan x by 1 minus tan x minus 1. Simplified. What we get? E power limit x tends to 0. 1 by x into, take LCM here, 1 minus tan x. This is 1 by 1. So 1 plus tan x into 1. 1 plus tan x. Here, minus 1 into 1. Minus 1 plus tan x. Correct? Plus 1 minus 1 cancels. What we get? E power limit x tends to 0. Correct? 1 by x into tan x plus tan x is 2 tan x divided by 1 minus tan x. We know tan x by x is 1 as x tends to 0, correct? So tan x divided by x is 1. So what is left? E power 2 into 1 divided by 1 minus tan 0 is 0. So answer is e square over. Simple question on 1 to the power infinity. Learn the formula. Limit x tends to a, f of x power g of x is equal to e power limit x tends to a, g of x into f of x minus 1. The base should become 1 and the power should become infinity. Then only we can apply it. Answer is e square. Some results are given here. Limit x tends to infinity, x plus alpha by x plus beta power x plus k is e power alpha minus beta. I can prove it, can give a proof of this. This also becomes 1 to the power infinity form. As x tends to infinity, the base is becoming 1. See, ratio of the leading coefficient. Here, degree of numerator is 1, degree of denominator is 1. So, ratio of the leading coefficient. Coefficient of x in the numerator by coefficient of x in the denominator. 1 by 1 is 1. 1 to the power infinity. I can apply that formula. What is that formula? E power limit x tends to infinity is given. Whatever limit is given, same thing you write. G of x into f of x minus 1. G of x means write the power first. Power is x plus k into f of x minus 1. X plus alpha by x plus beta minus 1. Correct? This is equal to e power limit x tends to infinity. What we have? X plus k into, take common denominator, x plus beta. Here, take LCM 1. X plus alpha into 1, x plus alpha minus x plus beta. X will cancel, alpha minus beta. And here, coefficient of x is 1, coefficient of x is 1 in the numerator denominator. So, ratio of the leading coefficient. So, this by this, as you take x tends to infinity becomes 1, already given this, because degree of numerator is 1, degree of denominator is 1, degree means highest power of x 1, power of x1 in the denominator as well. So take the ratio of the leading coefficient. Coefficient of x1. Coefficient of x1. 1 by 1 is 1. 1 into alpha minus beta is alpha minus beta. So e power alpha minus beta. Okay. Can take it as a shortcut also. Same I can prove this also. Limit x tends to infinity is given. I think x tends to 0 it should be. Okay. Not infinity. This should be x tends to 0 here. X tends to 0. a power x plus b power x plus c power x by 3 to the power 1 by x. A power 0 is 1. B power 0 is 1. C power 0 is 1. 1 plus 1 plus 1, 3. 3 by 3, 1. 1 by 0, infinity. So it takes 1 to the power infinity form. This is correct. X tends to 0 it is. Okay. I'll apply the same formula. F of x power g of x. What should I write? E power limit x tends to 0. G of x. G of x means write the power first. 1 by x into f of x minus 1. What is f of x? F of x is base. This is f of x. The base is f of x and the power is g of x. So formula is e power limit g of x into f of x minus 1. A power x plus b power x plus c power x divided by 3 minus 1. So this is equal to what? E power limit x tends to 0. What we have? 1 by x into, take common denominator 3. Correct? So what we get? A power x plus b power x plus c power x minus 3. Minus 3 I can write it as minus 1 minus 1 minus 1 3 times. Correct? So that will be equal to, I'll write here itself, e power limit x tends to 0. What you do is this 3 keep outside and this x you bring inside. Interchange 3 and x. So denominator here will be x here. Minus 3, right? Minus 1 minus 1 minus 1. So this will be a power x minus 1 plus b power x minus 1 plus c power x minus 1. And we know a power x minus 1 by x is log a as x tends to 0. This by this log a. This by this log b. This by this becomes log c. So I'll write here that's equal to e power 1 by 3 into, apply limit for this, a power x minus 1 by x is log a. Correct? B power x minus 1 by x is log b. C power x minus 1 by x is log c. Correct? This is equal to e power 1 by 3 into log a plus log b plus log c is how much? Log of ABC using the property of log, and 1 by 3 can be taken to the power e power log ABC to the power 1 by 3. Exponential log will cancel out. What we get is ABC to the power 1 by 3, which is nothing but cube root of ABC. Hence proved. I have adjusted and wrote here and somewhere else. Please cooperate for this. Example is given here. So this is based on the previous result. X tends to infinity. X plus alpha by x plus beta power x plus k. What is the answer? E power alpha minus beta. 5 minus 3. Alpha is 5. Beta is minus 3. E power 8 is the answer. Within 3 seconds you can crack. Correct? Using this result. X plus alpha by x plus beta power x plus k as x tends to infinity. E power alpha minus beta. And the next one I am using the second result. For this it is e power 8. For this, based on the result, a power x plus b power x plus e power x by 3 to the power 1 by x. X tends to 0 it is. Okay. Answer is cube root of ABC. Cube root of ABC. Cube root of, what is that? A is 2, B is 4, C is 8. So this becomes cube root of 64, which is equal to 4. Okay. Cube root of 64 equal to 4. And application of, that is L'Hopital's rule, 0 by 0 or infinity by infinity. Differentiate numerator and denominator separately until you get a finite answer, until the indeterminate form is removed. Some examples are given here for L'Hopital's rule. F of x is given like this, root of 9 minus x square. You want to find this limit x tends to 1, f of x minus f of 1 by x minus 1. If you apply limit directly, what happens? This becomes f of 1 minus f of 1 divided by 1 minus 1, which is 0 by 0 form. So I am applying L'Hopital's rule. Differentiate numerator and denominator separately. Apply L'Hopital's rule. Apply L'Hopital's rule. What do you get? Limit x tends to 1. Limit x tends to 1. Differentiate numerator. We get f dash of x. And derivative of f of 1 is 0. Derivative of x minus 1 is 1. Now apply limit x equal to 1. We get f dash of 1. F dash of 1 can be found from this. F of x is given. So find out f dash of x from you. F dash of x is equal to derivative of root x. 1 by 2 root x. 1 by 2 root of 9 minus x square into derivative of 9 minus x square is minus 2x. So root 2 cancels here. We get minus x divided by root of 9 minus x square. Correct? Now you want to find f dash of 1. So put x equal to 1. F dash of 1 is got minus 1 by root of 9 minus 1. Correct? Minus 1 by root 8. Root 8 is root of 4 into 2. 2 root 2 is the answer. The required answer is minus 1 by 2 root 2. Differentiate numerator and denominator separately. F of 1 is constant. Derivative of constant is 0. Derivative of 1 also 0. So f dash of x by 1. Apply limit f dash of 1. F dash of 1 to find out that first find f dash of x and then put x equal to 1. Applying chain rule and getting the answer. Derivative of root x 1 by 2 root x into further differentiate terms inside the root. Derivative of 9 minus x square is minus 2x. Answer is minus 1 by 2 root 2. Another one, question based on L'Hopital's rule. If you apply limit directly x equal to 0, I get 0 minus sine 0 0 by 0 cube is 0. 0 by 0 form. We can apply L'Hopital's rule. Differentiate numerator and denominator separately. Apply L'Hopital's rule. Differentiate numerator and denominator separately. What we get? Limit x tends to 0. Differentiate the numerator. Derivative of x is 1. Derivative of sin x, cos x. Derivative of x cube, 3x square. Denominator 3 means 1 by 3. 1 by 3 keep outside. What we get? Limit x tends to 0. 1 minus cos x divided by x square. 1 minus cos x by x square is half. So answer is 1 by 3 into 1 by 2 is equal to 1 by 6. 1 by 6 is the answer. And limit, finding unknowns when the given limit is finite. This is also a JE concept. Suppose as x tends to a, if denominator is tending to 0, numerator should tend to 0 when the limit is finite. This follows by L'Hopital's rule. There is one question asked in KCT 2014. Many such questions are asked in JE exam also. The limit is pi is given, correct? Limit of this function is given to be equal to pi. That means limit of the function is going to exist finitely. See, as x approaches 1, what happens here? Denominator is becoming 0, correct? As x is approaching 1, denominator is tending to 0. Denominator 1 square 1, 1 minus 1 0. If denominator is 0, then numerator also should tend to 0. Numerator also should tend to 0 because limit is finite. If denominator is 0 and if numerator is non-zero, say 5 by 0 or 10 by 0. 10 by 0 means what? Does not exist, right? But right answer is already given to be equal to pi. If it is pi or some other number, say they give 100 also, no problem. The answer is same. The concept is same. The whatever right answer is given is a finite number. That means limit of the function is going to exist finitely. That is what you have to understand. So as x is approaching 1, if denominator is tending to 0, numerator should tend to 0. So what should I have is limit x tends to 1 of the numerator should approach 0. F of x minus 2 should be equal to 0. So limit x tends to 1, f of x. Limit x tends to 1, f of x is equal to limit of 2 is 2. That is 2 take the answer, minus 2 take the answer 2. Hence we get the answer. Limit x tends to 1, f of x equal to 2. Answer is 2. Such an important concept for JEE exams. Okay, many times questions are asked based on this. If denominator tends to 0, numerator should tend to 0 for limit to be finite. Otherwise, limit becomes infinite or does not exist. Suppose numerator is not becoming 0. If denominator is 0 and if numerator is non-zero, so 10, numerator is 10, denominator is 0, 10 by 0 does not exist. It can't be equal to pi, right? Because limit is already a finite non-zero number, and if denominator is 0, numerator should become 0 so that it takes 0 by 0 form. So we can apply L'Hopital's rule and remove that 0 by 0 form to get a finite number. Understood? So remember, as x tends to 1 or x tends to a, if denominator is approaching 0, if the limit is finite non-zero number, then numerator also should tend to 0. So by L'Hopital's rule, it takes 0 by 0 form. This is the most important question, most important concept. Many times questions are asked based on this in JEE exams. 1 to the power infinity is one of the most important. Sandwich theorem questions are asked, and based on the series expansions questions are asked, and this also the questions are asked. Finding the unknowns when the limit is finite, and if denominator tends to 0, numerator also tends to 0. And also sometimes you have to apply L'Hopital's rule here in this case to find the unknowns. Such kind of questions are asked in JEE exams. Please make a note of this. I'll be doing JEE problems also in the next session, okay? CET also I'll work out many questions. Please subscribe to my channel. Forward to maximum context. Forward to all the students. Even for teachers also it's quite useful, because even teachers have to prepare a lot to take JEE classes, right? If you listen to my classes, it's quite useful. I'm doing it in a very simple way. It's effective, correct? Effectively. Next one is the sandwich theorem. So if f, g and h are three real functions such that f of x less than or equal to g of x less than or equal to h of x, limit of f of x and limit of h of x both are equal to L, and the limit of the middle one is also L. G of x is sandwich between f of x and h of x. That's why sandwich theorem. So I can draw one graph for this, something like this: f of x, g of x and h of x, like this. F of x, g of x and h of x, something like this. This is at x equal to a. At x equal to a. This is L. This is L on y-axis. Okay. This is f, g and h. Three functions f, g and h are such that f of x less than or equal to g of x less than or equal to h of x. This inequation is satisfied if a is some real number, limit x tends to a of f of x and limit x tends to a of h of x. This and this both are equal to L. Then the limit of x tends to a of g of x is also L. If this and this, the first and the last, are approaching L as x approaches to a, even the middle one also approaches to the same number L. That is what? Limit x tends to a f of x equal to L, limit x tends to a h of x equal to N, then limit x tends to a g of x equal to L. Quite useful sandwich theorem. I'll be working on problems based on this for JEE level questions. Okay, please make a note of this. And one example is given: limit x tends to 0, x into sine 1 by x is 0. Because sine 1 by x is oscillating value, we know that it lies between -1 plus 1. Whatever may be the value of x tends to 0, 1 by x tends to infinity. Whatever may be the angle, sine function value is always a finite number between -1 plus 1. So this is -1 plus 1, a number between -1 plus 1, oscillating value into 0 is 0. A finite number into 0 becomes 0. So limit x tends to 0, x into sine 1 by x is 0. Sine 1 by x, if I ask what is limit x tends to 0 sine 1 by x, no, it does not exist, because it is an oscillating value. X tends to 0, sine 1 by x does not exist. Whereas x into sine 1 by x is given, it becomes 0. Limit x tends to 0, x into sine 1 by x is given, it becomes 0. X into sine 1 by x or x square into sine 1 by x, those things will become 0. A finite oscillating number into 0 will be 0. But this does not exist. X into sine 1 by x, as x tends to 0 will be 0. I'll explain more of this in the next class, okay? Even it applies for cos function. Limit x tends to 0, x into cos 1 by x is also 0. Newton-Leibniz formula. F is a continuous function on the closed interval AB. U of x and v of x are two functions, differentiable functions of x whose values lies in the interval AB. Then how to differentiate an integral? We need to learn this. Actually, it's a second PU topic, but sometimes questions are asked in limits also. The Newton-Leibniz formula is important. So d by dx, how to differentiate an integral? This is a definite integral. Lower limit is function of x, upper limit is also function of x. Lower limit is u of x, upper limit is v of x. F of t dt. The function of t is given here. So if you want to differentiate a definite integral, what does it say is integration and differentiation is going to cancel out. Substitute the upper limit. The upper limit is v of x. The variable is t. So put the upper limit here, f of v of x, into differentiate the upper limit minus substitute the lower limit, differentiate the lower limit. How to differentiate a definite integral where the lower limit and upper limit are variables, functions of x, and the function present here, the function to be integrated, is function of t. So what you do is integration and differentiation is going to cancel out and substitute the upper limit, f of v of x into derivative of v of x is v dash of x minus f of u of x into derivative of u of x is u dash of x. What does Newton-Leibniz formula tell? Just if you want to differentiate a definite integral, integration and differentiation is going to cancel out. Substitute the upper limit into differentiate the upper limit minus substitute the lower limit, differentiate the lower limit. That is what it's given here. It's called as Newton-Leibniz formula. Some examples are given here. F of x given as integral from a to x t into sin t dt. Find f dash of x. So differentiate on both sides. D by dx of f of x is equal to d by dx of integral from a to x t into sin t dt. Correct? So now d by dx of f of x is f dash of x. Now here I am applying the Newton-Leibniz formula. The variable for integral is t and the upper limit is x, lower limit is a. So integration and differentiation is going to cancel out. Substitute the upper limit. What do you get? X into sin x. Substitute the upper limit. X into sin x into derivative of x1. Substitute the lower limit. A into sin a into derivative of a 0. Substitute the upper limit. Differentiate the upper limit multiplied by derivative of upper limit minus substitute the lower limit multiplied by derivative of lower limit. A is a constant, derivative of constant is 0. This part is gone, 0. So what is left is f dash of x is x into sin x. Understood? This is the example. F dash of x is equal to x into sin x actually here. X is missing, correct? X into sin x. That is what we got the answer. Next one. X is given as integral from 0 to y. Here it's a function of y here. Want to find the second derivative. So you differentiate with respect to y. D by dy of x is equal to differentiate with respect to y on both sides. Differentiate with respect to y. 0 to y dt by root of 1 plus 9t square. Correct? Left hand side will be dx by dy. Dx by dy. I am differentiating with respect to y because upper limit is function of y. Depends upon the lower limit and upper limit. If lower limit, upper limit is function of x means you differentiate with respect to x. Here lower limit is 0, upper limit is y. So differentiating with respect to y. Substitute the upper limit. The integration and differentiation is going to cancel out. 1 by root of 1 plus 9y square into derivative of y with respect to y1. Minus 1 by root of 1 plus 9 into 0, 0 into derivative of 0, 0. So what we get is 1 by root of 1 plus 9y square. This is 0. Now take reciprocals. Dx by dy and dy by dx are reciprocals. No? So dy by dx is root of 1 plus 9y square. Dy by dx. I got the reciprocal of dx by dy as dy by dx. Now again differentiate this, double differentiate this. D square y by dx square. D square y by dx square is the second order derivative. Differentiating the first derivative, we get the second derivative. Derivative of root x. 1 by 2 root x. 1 by 2 root of 1 plus 9y square into derivative of 1, 0. Derivative of 9y square is 18y into dy by dx. Correct? So 2 1s are 2 9s are cancels. 2 1s are 2 9s are. So what is left? 9y divided by root of 1 plus 9y square into dy by dx. We got it as root of 1 plus 9y square. Substitute from there. Correct? From the earlier step. This will cancel. So we get 9y. So d square y by dx square. Compare with ay. So a should be equal to 9. This is the application of Newton-Leibniz formula. Differentiating a definite integral where the lower limit, upper limit are the variables. Next one. Last question I think. Then we can conclude from this. Integral from 0 to x square. So upper limit is function of x square. No, I'll differentiate with respect to x. D by dx of integral from 0 to x square f of t dt is equal to d by dx of x into cos pi x. X into cos pi x. So integration and differentiation will cancel out. Substitute the upper limit, differentiate the upper limit, minus substitute the lower limit into derivative of lower limit. In place of t, put the upper limit. What we get? F of x square into derivative of x square 2x minus substitute the lower limit. In place of t, put the lower limit. Lower limit is 0. F of 0 into derivative of 0, 0. Here you need to apply the product rule for derivatives. First into derivative of cos minus sin pi x into derivative of pi x is pi plus cos pi x into derivative of x is 1. Correct? This is 0. So what we get? 2x into f of x square. This part I won't write, that is 0. Correct? Here minus pi x into sin pi x plus cos pi x. So much we get. We need to find f of 4. So put x equal to 2 because 2 square is 4. Put x equal to 2 on both sides. What do you get? 2 into 2, 4. F of 2 square 4 is equal to minus 2 pi into sin 2 pi, putting x equal to 2. I'm getting like this. Sin of n pi is 0. Sin 2 pi is 0. 0 into minus 2 pi 0. Cos 2 pi is 1. So 4 into f of 4 is 1. So from this I get f of 4 is equal to 1 by 4. In this session, I have explained the concepts of limits with examples, various concepts. It might be L'Hopital's rule, 1 to the power infinity, explained series expansions, and also given the proofs for many of the results, many of the shortcuts or time-saving results, limits of trigonometric functions, limits of exponential and logarithmic functions. Many concepts we have discussed in this. Newton-Leibniz formula, correct? Applications of Newton-Leibniz formula, L'Hopital's rule, series expansion, Maclaurin series expansion, left hand limit, right hand limit, limit of function, when does it exist, correct? Many things were discussed with examples, which is quite helpful for various competitive exams like CET or any equivalent exam to CET, even JEE exams, NDA, and various other competitive exams. It's quite useful. In the upcoming days, I'll be in the coming days, I'll be uploading many more videos. Please subscribe to my channel. With this, we'll conclude on the topic of limits. Synopsis with examples is done in this session, and in the next session we'll be discussing the JEE questions connected to limits and also PYQs and many more things. With this, we'll conclude. Thank you.